In this episode, you will learn about sleep and its importance for learning. You will learn about how new information is encoded in the brain and the importance of non-REM slow wave sleep in the solidification of those new memories. You will learn as well about the role of beta-amyloid plaques in Alzheimer's dementia and the glymphatic system and its ability to remove those beta-amyloid plaques. And you will learn a couple different theories about new ways to increase our ability to learn, as well as improve our sleep quality and decrease our risk for Alzheimer's dementia. Sleep is a very important activity in human function, and it serves a really important role in learning. So, one way to think about sleep and how it impacts our learning is to think about when the sleep occurs in relation to the learning. So, the sleep that happens before a session of learning is really important for our information's first arrival into our hippocampus. Our hippocampus is kind of like it's like a receiving center, sort of like an inbox, and it's not the same as sort of deep integration of that knowledge into long-term memory, but rather it's more short term. So what happens is that we see there's this one study that was done with college students that showed that when they were sleep deprived, they had difficulty learning new information, and so learning that can happen after sleep deprivation can be lost if we don't get sufficient sleep. And then this compares to sleep that happens after our learning, which is really important for consolidating our memories and consolidating our learning and taking it from the hippocampus out to the outer cortex of our brain. So what happens is that during these slow wave parts of our sleep, the deep non-REM parts of our sleep, what's happening is these patterns that are repeating, these learning patterns that are in our hippocampus are actually played through multiple times more quickly, like 10 to 15 times more quickly. So if you think about like playing the piano, for instance, if you're trying to learn a different progression, you'll start by playing it slowly, and then eventually it'll pick up and you'll be going much more quickly, 10 to 15 times more quickly. And that's kind of what happens in our sleep consolidation of knowledge, is that instead of the short progression or the slow progression of what we are learning, it's repeated over and over again, helping to transfer it from short-term to long-term memory into our outer cortex. This is, like I was saying, this is mediated through this non-REM sort of slow wave sleep that happens. And in fact, this slow wave sleep is really changed by our aging process. And actually, it's not just the aging process, it's really related to beta amyloid plaque aggregation and changes in our medial prefrontal cortex. So our medial prefrontal cortex is at the front of our brain, part of some of the structures that are the last on us to form. And what happens is in this one study, they were looking at the changes in older adults and indeed changes in that area of the medial prefrontal cortex, like changes like shrinking of the substance there, or of deposits of beta amyloid plaques forming. This can get in the way of this important electrical signaling of the slow waves that's happening in this slow non-REM sleep. And so what happens is sort of this vicious cycle happens as we get older, where actually around the age of 50, this is according to the PhD Matthew Walker, who does research on sleep. He says around the age of 50 that about 50% of our slow non-REM sleep is present, and that drops precipitously, nearly undetectable by the age of 80. So past then, we're getting very little of this slow wave non-REM sleep, and so we're having difficulty with consolidating these memories into long-term memory, which is so important for our learning. What can happen then in this vicious cycle is that we get worsened sleep quality, and because we're getting worsened sleep quality, that actually increases the amount of beta amyloid plaques that are building in our brain. And as they build, specifically in the medial prefrontal cortex, that continues to inhibit and get in the way of this of this slow wave non-REM sleep. So it sort of creates a snowballing effect that results in worse sleep quality and worse memory and worse long-term memory formation. So I touched on this a little bit with what I was just speaking about, which is the role of amyloid plaques, beta amyloid plaques, and dementia and Alzheimer's. So beta amyloid plaques are these proteins. You can think of them like little, chunks of protein, little pebbles that get stuck in our brain. They're produced in our brain, and they're washed away on a daily basis as we're sleeping and also during other activities like exercise. So what happens is when we actually go to sleep, there's a system known as the glymphatic system. So just like our lymphatic system, which carries our lymph to our lymph nodes, it's a fluid that helps to clean out different tissues and rid our bodies of some of these different sort of toxins and things like that in our body. And so what's happening in the glymphatic system is this actually a system formed by the glial cells in the central nervous system. And along our blood vessels, they line up and they form these canals where fluid, cerebral spinal fluid, can flow. And what it does is it's every night there's a washing out of these protein plaques that are forming in our brain. And that's one of the most important features of sleep, is that it allows us a time for this to all wash out. And that's because different imaging studies, mostly on mice, have demonstrated that the amount of space between the cells, the intercellular space, can increase by as much as 60% when we are asleep. And so if you imagine, it's like our cells are our neurons are like our teeth, and this is sort of like flossing between the teeth. When we go to sleep, this intercellular space expands, just like as if our teeth were to move apart, and that allows for there to be an easier washing out of the space between the teeth. So if we're not getting enough sleep, that there's no washing out of the space between the cells, between the neurons. And so you get these hunks of beta amyloid plaque that get stuck there, and that can impede our neurotransmission. It can get in the way of our brain's function. So it's really important that we get good sleep quality because it's been found that as much as about 40% of our total amyloid plaque quantity can be removed in a night of sleep. And actually, there are very severe effects of even just occasional sleep deprivation. A sleep deprivation of 36 hours in one study was shown to have a reduction, was shown to have an increase in beta amyloid substance in the brain by 25 to 30%. So the impacts of sleep deprivation can be quite severe. And actually, another interesting mouse study that I was reading was looking at the importance of body posture, whether that had any impact on the glymphatic system and the washing away of the beta amyloid plaques. And actually, this one study found that the mice that were laying sideways actually had a greater glymphatic current. So there's this theory out there of whether or not being a side sleeper is actually an evolutionary advantage in the protection against Alzheimer's and dementia. So, and there's also some theories out there about the role of gravity, in that for a lot of different creatures, they tend to sleep in inclinations that slightly have their head above their feet to allow, presumably, that there'd be some benefit for gravity in the glymphatic system. So there is some question about whether it would be beneficial to raise the head of the bed something like 6 inches to allow for greater drainage of our glymphatic system. So these are all just some interesting questions about the glymphatic system and how we can increase the amount of beta amyloid plaque reduction that's happening each night. Another interesting thing about this that I wanted to mention is that the consumption of omega-3 fatty acids has been found, otherwise found in fish oils as well. There was this one study finding that there was greater clearance of beta-amyloid plaques by the consumption of fish oil or omega-3 fatty acids. I think that this is presumably related to the inflammatory role, but I'm not quite sure. But so that, as well as exercise is shown to have a greater amount of flow in the glymphatic system. This was in a mouse study, so looking at mice that were exercising on like a hamster wheel, and it was found to have greater removal of the beta amyloid plaques. So it's another reason why exercising can be really important. And I got a little taken away a little bit on the subject of Alzheimer's, dementia, and beta amyloid plaques. But one other thing that's important from the learning perspective and our learning consolidation is that our bodies are very contextual, and we learn within a different context, and our senses are very important in allowing us to also encode that information. So there has been some question about whether or not we could leverage this to increase our learning by including different scents and sounds, as well as different physical environments, in order to increase the amount of senses that are activated during our learning. So for instance, it's been found that students who study in the environment that they're going to take their test on average score higher. And similarly, it's been known that that scent has a very strong role in our memory formation. So there's been some question or theorizing around whether we could, if we're trying to learn a new topic, be exposed to a certain unique scent while we're learning, and then whether or not we could have that scent present while we were sleeping as a way to encourage the consolidation of that memory into long-term memory. Similarly, with music or specific sounds while we're learning, by playing those at a low threshold to where they're not enough to awaken us at night, that whether or not those can help to help our long-term memory formation while we're sleeping as well. So these are just some theories, but I find them really interesting because I think that it touches on our reality as humans of not just being, just only visual creatures, but also our sense of smell and hearing and feeling. These are in taste. These are all things that we have been evolutionarily using to know our environment and to learn new things, and so they can potentially be touched upon in order to allow us to perform better and learn better. So these are a couple of thoughts about sleep. So I think some of the most important takeaways is that sleep is incredibly important. And as we're getting older, it is important to try to maximize our glymphatic system flow as much as possible to wash out as much of those beta amyloid plaques as we can. So we can do that by exercising, by consuming fish oil or omega-3 fatty acids. And we can do that by getting plenty of sleep, at least 7 hours a night, if we can. There are some experimental questions about whether sleeping on your side or lifting up the head of the bed slightly could help with that as well, but I couldn't tell you confidently whether or not that would actually have any significant effect. But nevertheless, those things are interesting, and as we're thinking about learning for students, I think the takeaway here is that no all-nighters. All-nighters do not work. You will not be able to take in new information, and you're getting in the way of your consolidating of that memory the night before. So make sure that you're getting plenty of rest. And secondly, you can consider using things like scent and sound to be able to give your body some more other tags to attach to your new learning and your new memory formation, and see if that has better outcomes for you, or at the very least, just studying in the place where you're going to take the test will likely produce some positive results for you. So those are some thoughts for today. I hope you found that helpful, and have an awesome day.